Alright, here we are in Learning Target 2 in the Radicals and Rationals unit. We just got done solving equations with radicals and rationals, and now in Learning Target 2 we're going to focus on graphing them. Similar to first semester when we started graphing transformations, we are going to look at what's called a parent function. The parent functions such that there's no transformation yet done to them. Our first parent function is going to be the square root function. And we're going to need to plot some points in order to graph this. So some numbers that we know we can take the square root of, some easy ones that you might want to resort back to every time you actually come across a square root function would be 0. Square root of 0 is always going to be 0. 1, the square root of 1 is always going to be 1. And how about the square root of 4? The square root of 4 is also always going to be 2. And I think 3 points is going to be enough for us to sketch our graphs. We can do more, but I don't think it's necessary. So in sketching these, we're going to use those 3 points. So 0, 0, 1, 1, 4, 2. That's going to look generally like that. Now there's no input value that can be less than 0. Because we can't take the square root of a negative number. If I go less than 0, it's going to be negative, so that can't happen. It becomes imaginary. So that's why the graph tails off only to the right in the positive direction. Similarly, for the cube root function, I'm going to plot some points. Now for cube roots, we can have positives and negatives. One number that we can use here for the cube root, we can use 0 once again. Cube root of 0 is always going to be 0 because 0 times itself 3 times is always going to be 0. And the cubed root of, let's say, how about 1 is always going to be 1 because 1 times itself 3 times is always going to be 1. And how about the cube root of 8? That should be 2 because 2 times itself 3 times would give me back 8. And if I go in the opposite direction, negative 1, the cube root of negative 1 is going to be negative 1. And the cube root of negative 8 is going to be negative 2, because negative 2 times itself 3 times would give me back negative 8. Now I used a lot more points here than I did for the first one because I'd like you to see a bigger picture. However, I think just for the purposes going forward for transformations, you really only need 3 of them. And I would choose these 3 to focus on because it gives you some negative values. It gives you what's called the inflection point at 0, 0, and it also gives you a positive number. So graphing these, I'm going to graph all of them for this purpose. 1, 1, negative 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 2, and negative 1, negative 2, negative 3, 4, 5, 6, 7, 8. So it's going to look like that. There's the cube root. Now, we have to be familiar with our parent function. So we are going to focus on just these 3 points. And now looking at those 3 points, in part 2 we're going to see what actually happens under this transformation. So if you remember back from first semester, x subtract 2. So we're subtracting 2 away from the input. So this is only going to affect the input. What's going to happen is exactly the opposite. We're actually going to be adding 2 to my input. The positive 3 is outside the parentheses, or it's not connected to the x in any way, so it's going to affect the output. And the output is always affected exactly like you think it would be, not the opposite, unlike the input. We're actually going to add 3 to my output values. So now if I just compare to my parent function above, I'm going to make another table. If I take 0, 1, and 2, so I'm going to write them off to the side. This is my parent function, 0, 1, and 4. And then my output values for the parent function would be 0, 1, and 2. I'm going to write this in a different color now. So my new coordinates for this transformed square root will be, I'm going to add 2 to all my input values. So I'm going to take 0, I'm going to add 2 to it to get 2. I'm going to take 1, I'm going to add 2 to it to get 3. I'm going to take 4, and I'm going to add 2 to it to get 6. Now for my output, I'm going to add 3. So my former output values, 0, I'm going to add 3 to. I'm going to add 3 to 1 and get 4. I'm going to add 3 to 2 to get 5. And now I have 3 new points that you can see. 1, 2, 1, 2, 3. And I have 3, 4. 3, 4. And I have 6, 5. So right there. Alright, now for our cube root function, what we're going to do is follow the same procedure. We're going to make a table, and we're going to list the parent function's values on the outside. So -1, 0, 1. These are the 3 that we're going to focus on. And then -1, 0, 1. And on the inside, we are going to write exactly what happens to the input values and the output values. So now we're adding 1 to the input, which really means we're going to be subtracting 1. We're adding 4 to the output, so that's actually what we're going to be doing. It happens just like we would think it would happen to the output, but it happens oppositely to the input in relation to how we would think it happened. So now, if I'm going to be subtracting 1 away from -1, I'll have -2. Subtracting 1 away from 0, I have -1. Subtracting 1 away from 1, I get 0. Adding 4, so I'd end up with a +3. Adding 4 to 0, I have 4. Adding 4 to 1, I have 5. So now I have 3 points that I can sketch my graph. So I have -1, 4, -2, 3, and 0, 5. So it's going to look like just like that. And we would say verbally that this actually went to the left 1 and up 4 from the parent function. So in general now, when we look at the rules, which we have summed up in first semester, but now we're looking through a lens of square roots and cube roots. When we're adding or subtracting a number outside the radical, the graph moves exactly that amount in the y direction, because it affects the output. The outputs are always the y's. When we're adding or subtracting a number inside the radical, the graph moves exactly the opposite amount in the x direction. It's because it's affecting the input. Alright, there you go. Now go down to the Your Turn section and complete your graphs. Don't forget to relate back to the parent functions. I would highly suggest using tables and creating your 3 points. Those 3 points can be used for all square roots and all cube roots alike, and then you can find your new values to create your graph.